Hello, Luke. Welcome to Lesson 50. So today we've got our work cut out for us. Today we're going to be going over a number of things, and these are going to be key concepts that we will be building off of in the upcoming lessons. So very important lesson today. There will be some notes, so make sure you've got your notebook handy and a pencil or a pen, and we can write them down as we go. So quick summary of today's lesson. We'll be looking at polynomial equations, ordered pairs, and then the Cartesian coordinate system. All right, so we've got our work cut out for us. Let's begin by checking off the first one here, polynomial equations, and let's talk about those. All right, so what is a polynomial equation? Well, just as a quick review from yesterday, we talked about polynomials, what they were, and their degrees, and so forth. So if I have a polynomial that maybe looks like this, 6xy, the degree for that, what would be the degree for this term? Hopefully you recognized that, I apologize, hopefully you would recognize that this is a second degree polynomial. Why? Because we take the term and we add up the exponents of the variables. So this has an exponent of 1, this has an exponent of 1. We add them up, we get a second degree. All right. In like manner, if I had 6m to the third, what degree would this polynomial be? And hopefully you recognize that this is the third degree, right? And then we can have something that looks like this. So if I have xy plus 2zw, this would be a polynomial still, right? Because a polynomial definition does include polynomial terms being added to each other. So these are both polynomial terms. They're being added to each other. This would still be considered a polynomial. What degree would it be in? Well, this would be in degree what? Degree 2, or second degree, right? Again, because we look at each term individually and we add up the exponents for the individual terms, and the most we end up with is 2. So the degree is 2. All right, and then maybe just one more. So if I have 3abc plus 4x squared plus 5z, what would be the degree of this polynomial? And again, hopefully you got this one right, but the degree would be 3. It has the degree of 3. Okay, and that's because our term with the highest degree is this one, because if we add up the exponents, we end up with 3, which is larger than any of the other terms. So we have a degree 3 polynomial here. Okay. All right, so just as we're just doing that as a little bit of a review to make sure that we've got that down so that we can then understand polynomial equations. So if we're talking about polynomial equations, we've done many polynomial equations up to this point. This would be considered a polynomial equation. All right, all it is two polynomials being set equal to each other. All right, so this is a polynomial, this is a polynomial, they're being set equal to each other. This is a polynomial equation. How easy is that? So we've been dealing with these all along, we've just never really given them a name. All the equations that we have been doing have been polynomial equations. Now, some of them might be a little bit more complex. We might have something like this, you know. Something like this. This would still be a polynomial equation, correct? Because each term on this side is a polynomial. Each term on this side is a polynomial. They're set equal to each other, so we have a polynomial equation. All right? Very easy. Now, that being said, just like when we talk about polynomial terms, we also have a degree that we give polynomial equations. And the rationale is the same that we used when deciding the degree of a term. So looking at this full equation, if I were to ask you what's the degree of this equation, well, it's very simple. We just go through each term and look at the degree of each term and select the one that's the largest, and that will be the degree of the equation. So in this case, it's fairly simple. This has a degree of 1. This has a degree of 1. This has a degree of 0. This has a degree of 1, degree of 1, degree of 1, degree of 1. So the highest degree term we have in this equation is a degree of 1. So this would be a first degree polynomial equation. So it's just that simple. There's really no difference between deciding the degree of an equation and deciding the degree of an expression. Okay, so I think that brings us to a definition. So we'll reveal this one. Let's write this down in our notebooks. What is the degree of a polynomial equation? Very simple. It matches the degree of the term with the highest degree in the equation. All right. So write that down, and then we will continue. All right, so just as a quick recap, or maybe a little practice here, let's make sure that you've got this down. So if I have an equation such as 3x squared plus zy, well, yeah, zy equals 4x squared, what would be the degree for this equation? What would be the degree? Yeah, I'll write that here. Degree. All right. Well, looking at it, we'd look at each individual term, and we would say, well, this has a degree of 2. This has a degree of 3. This has a degree of 2. So the highest degree is 3. So this is a third degree. Whoops. Degree equation. I might even say polynomial equation. All right, so that is how we find the degree for an equation. Now, one other note I might just make on this is this would be considered an equation in 3 variables. All the equations that we've been dealing with up till now have been equations of 1 or perhaps 2 variables. This is an equation of 3 variables. And all that means when I say that is that the equation has 3 separate variables. We have an x, we have a z, we have a y, we have an x, which we already counted, we have an x, which we already counted. So we have 3 different variables being used, x, z, and y, or x, y, z. Okay, so it's a third, it's an equation in 3 unknowns. Okay, up here we have an equation in 1 unknown because the only variable is x. All right, so just kind of be familiar with that. If I say it's an equation in 2 unknowns, it just means there's 2 variables. If I say it's an equation in 4 unknowns, it's an equation with 4 variables. Okay, very good. Let's continue. All right, so let's talk about polynomial equations of 2 variables. Let's kind of emphasize that because that's really going to be the focus in the upcoming lessons is equations that have 2 variables in it. So let's talk about that. What if I have an equation that is y is equal to 2x plus 2? Okay, so here I have an equation. It's in 2 unknowns, so it's in 2 variables. It's a polynomial equation. The highest degree is 1, so it's a degree of 1. And I'm going to try to solve it. All right. Now, what we're going to notice here is let's just step through it here. So let's say I give you a value for x. Because this is in 2 variables, it's impossible to just simply solve this equation like we would an equation that, let's say, is in 1 variable. If I have an equation that's in 1 variable, such as this, we can actually solve this very easily and get it down to what this variable is equal to, right? And then we know the number hiding behind that variable, okay? But in this case, we can't really do that. I mean, I could solve for x, but that solution is going to have a y in it, all right, which isn't really a nice number. Notice it's already being solved for y. Y equals this, all right, but the problem is this has a variable in it, and so it's not a nice known number. It still has an unknown, all right? So when we have 2 variables, we can't really get it down to just a number, all right? So what we need to do is we need to say, well, okay, what could x be? Let's give a value. Oops. Let's give a value for x. Let's say x is equal to 1. All right. And if x is equal to 1, then what is y equal to? So that would be the question. What is y equal to when x is equal to 1? And to find that out, we just simply plug in the 1 for the x. So I'm going to rewrite this equation, and I'm going to plug in this 1 for x. And then I can solve for y. So y is going to equal 2 plus 2, which is 4, right? So y is equal to 4 when x is equal to 1. Okay? That being said, that's just one solution, right? You may have realized that. Well, what happens if x is equal to 2? Is y still going to be equal to 4? Well, if we solve that, we're going to say, well, y is going to be equal to 2. Now we plug in this 2 for the x plus 2. And this is going to be equal to 2 times 2 is 4 plus 2 is 6. So y is equal to 6 in this case. So when x is 2, y is 6. When x is 1, y is 4. And I think you can recognize that I could really go on and on and on with this forever. So I could just keep selecting values for x, plug them into the equation to find the corresponding value of y. All right. So there are infinite solutions to this equation. Infinite solutions. So if I were to ask you, tell me all the solutions for this equation, well, you would say, I'm not going to be able to do that because I would be writing forever and ever and ever and ever. All right. Now, believe it or not, tomorrow we will talk about a way to find all the solutions for this without writing forever and ever and ever. But we'll leave that for tomorrow. Right now, just suffice it to say that there are infinite solutions for this equation. And there are actually infinite solutions for any equation that has two variables. Okay? With two variables, that's a first degree equation. All right? Well, let's just do one more. So let's give x just one more value here. What if x is equal to 3? All right? And you might maybe even start to do this in your head. If x is equal to 3, well, let's just plug that in for the x, right? And then you're going to end up with 2 times 3 is 6 plus 2. Y is going to be equal to 8. All right? So when we talk about solving this particular kind of equation, we have terms that we use. And the first term is an independent variable. We need to select an independent variable. So let's throw up a definition here. So an independent variable is the variable for which we assign a value. Okay? We usually denote it as an x. So the variable, the independent variable is the one that we first choose a value for. Like this x up here. I first said, well, let's just give x an x value. And it could be any value. You know, pick your favorite number. What would you like it to be? X could be 1, x could be 0, x could be -1, x could be 1,000,000. Whatever your favorite number is, you can select it to represent x. All right, so x is very, very free. We can really choose anything we want for the x. So he is independent. All right, it's just some value that we assign. We usually denote it as an x. So obviously not all equations will be written in terms of a y and an x. Maybe there'll be an a or a b or a c or a d or a x and a w or something like that. But in general, when we have an equation, we like to use the variables x and y if possible. All right. Sometimes it makes more sense to use a different variable, and then we need to select one of those to be the independent variable. But most of the time, they're going to write these two variable equations with the variables x and y. And when they do that, it's just understood that the x is going to be the independent variable, and y is going to be, this next definition here, y is going to be the dependent variable. All right, so we have the independent variable, the x, and then we have the dependent variable. And the dependent variable is basically what it sounds like. The dependent variable depends on something else. It actually depends upon the value that we select for x. So y is only going to be 4 when x is 1. in this case. Y is only going to be 6 when x is 2. Y is only going to be 8 when x is 3. So this y depends upon the value of x. If x is free and we choose whatever we want, well, that will dictate what the y will have to be as well, corresponding to that x. Okay, so the y is not free. We don't just select any value for y. We select any value for x, and that dictates what y will be. It is dependent on the selection for x. All right, so hopefully that makes sense. That's some terminology that we will be using a lot, and it's very important to make sure that that's clear in our head. The independent variable is the one that we choose. The dependent variable is the variable that we end up with based upon what we chose for the value of the independent variable. So when we have solutions to this equation, so if I maybe just change my color, this is a solution. This is a solution to the equation. X equals 1, y equals 4. This is another solution to the equation. When x is 2, y is 6, and this is another solution. And we could keep going on and on and on and on with more solutions. Okay? Now, it gets very tedious always writing out x is equal to something and then y is equal to something else. So, as a shortcut in math, we've developed a way to write these solutions. And the way is pretty simple. It's called an ordered pair. So an ordered pair just looks like this. It's a set of parentheses, and inside the parentheses we have two numbers, a pair of numbers, okay, separated by a comma. The first number represents the x solution. The second number represents the y solution. So the first number is the independent variable, and the second number is the dependent variable. All right, so we have a solution here of x equals 1, y equals 4. So we'd write that as an ordered pair, 1, 4. To write the second solution as an ordered pair, we would also write this as 2, 6. All right, and then third would be 3, 8. All right, these are all solutions to this equation. Okay, now keep in mind, when you see an ordered pair, probably the most important thing is to remember that that first number represents the x, and the second number represents the y. So this ordered pair, 1, 4, is very different than this ordered pair, 4, 1. All right? This ordered pair would tell us that you plug in a 4, and you're going to get back a 1. And that is not what happens here. If I plug in a 4 for x, I get, for 2 times 4 is 8 plus 2 is 10. I do not get a 1. All right? So remember what this means. This first number is the x. The second number is the 4. If I plug in a 1, I should get back a 4. If I plug in a 2, I should get back a 6. If I plug in a 3, I should get back an 8. All right? And if you wanted to check these, just to show that these are indeed solutions, let's take our equation, y equals 2x plus 2, and let's just make sure that these are, in fact, solutions. Well, let's plug in the 1 and the 4. So the 1 represents the x. Whoops. We'll put our 2, and we'll just plug in the 1 for the x. The y is equal to the 4. So we still have this plus 2. The y is going to be equal to a 4. Now, we have a 4 on the left side. 2 times 1 is 2, plus 2 is 4. So that checks out. 4 does indeed equal 4. It's a true equation. So this is a solution to the equation. Now, if I choose to use the 2, 6, I would say, well, let's see, the y would have to equal the 6, right? The second number. Then we have our 2 times the first number, which is a 2. Plus 2, and we end up with 6 is equal to 2 times 2 is 4 plus 2 is 6. It checks out. That's a solution. And I could even do this for the third one. Y is going to be equal to 8 equals 2 times the x, which is the 3, plus 2, and we end up with 8 is equal to 6 plus 2 is 8. Again, it checks out. All right? So that's just proving that these indeed are solutions. And remember how I got these? I selected an x, plugged it in, and found out what the y was in correspondence to that. Okay? All right. Now let's get back to our definitions. So now in your notebook, go ahead and write down what an ordered pair is. It's a pair of solutions for any equation in two variables. The first number represents the x variable, independent variable, and the second number represents the y variable, dependent variable. I'm just looking at this now, and I have a silly typo here, so we will fix that, I think. There we go. So it should be variable. Variable. There we go. Okay. All right. Very good. So once you've written that down, let's move on. Now we're going to kind of set that aside for right now. We'll talk more about ordered pairs and equations in two unknowns tomorrow. But right now, we're going to introduce a new system. We're going to introduce the rectangular coordinate system, otherwise known as the Cartesian coordinate system. All right, so let's first begin by throwing in a picture here. Let's see, we'll go with this one. And wait for it. All right, so when we talk about the rectangular coordinate system, we're actually talking about a way of expressing ordered pairs, of graphing ordered pairs. So we've already talked about what an ordered pair is. We'll just actually tell you what. Let's go back to our other page here. So we had 1, 4, 2, 6, and 3, 8. So we had some ordered pairs of 1 and 4, 2 and 6, 3 and 8. Okay? And it's nice, and we'll find out more about this tomorrow, but it's nice to be able to graph these. All right? Everything else up to this point we've worked with, we've been able to graph on a number line, right? If I had, 3x is equal to 9, you might say, oh, well, x is then equal to 3, if I divide out the 3 on both sides. And if I wanted to, I could graph that on a number line. I could say, okay, here's my 0, here's my 1, here's my 2, here's my 3. This is x is equal to 3. That's where he lives on the number line, right? Now, in this case, though, this solution has two numbers. It has an x coordinate and a y coordinate, all right? So we can't graph that on a simple one-dimensional number line. We actually have two numbers. We need to go to a two-dimensional number line, so to speak. All right, and so to do that, we're going to use this graphing paper piece that I've put down here. That'll make things a little bit easier, and we're going to describe how to graph these 3 points right here. All right, so when we talk about the rectangular coordinate system or the Cartesian coordinate system, we're actually talking about, a system of two number lines. So we're going to draw one number line, and maybe we'll do it in black. One number line here, and this should have an arrow on both sides. So we'll just do this again here. Let's see if we go like this. Try to get this somewhat straight, and then maybe we'll just, no, that's not going to work. We'll try to go this direction. And then maybe we can move it here. That's close enough. So we have one line going across the page. All right. This is known as the x-axis. So let's write that down. This is the x-axis. Okay. So that's the first thing. Now we also have a y-axis. Only that one is going straight up and down. So we'll draw that one as well. So, whoops, we don't want red. We'll go black again. And we've got this guy, and he's going up and down. And then up and down this way. That's pretty close. All right, so that is our our y-axis. All right, so for this Cartesian coordinate system, we have two axes, the x-axis and the y-axis. Now, each one of these axes you could think of as being a number line, All right. And the home for 0 on the number line is right in the middle. Okay. So for the x-axis, the 0 is right here. Right there. That's the x-axis 0 right there. All right. It's also the up and down y-axis 0. Okay. So that's kind of the 0 point. Right here, if you think of this as a number line going this direction, that's the 0. And if you think of it a number line going straight up and down, that's the 0 for the number line there. All right. And then after that, for each one of these squares, we have a number or a unit in our number line. Okay. If you kind of erase everything else around this picture and just think of this horizontal line, it's basically just a number line. Okay, and then we also have a number line going up and down. So we have this number line for the y-axis. And he's going up and down this direction. Okay, pretty straightforward. For each of these numbers, we have a unit. So let's say, well, for the y-axis, it goes positive as you go up. So we start with 0 in the center. And as we go up, we go positively. So this is a 1. This is a 2 on the number line. This is a 3 on the number line, and a 4 and a 5. Okay? As you go down, you go negative. So this is 0. This is a negative 1, negative 2, negative 3, negative 4, and negative 5. Okay? For the x-axis, it works just like our normal number line works. So this is a positive 1, positive 2, positive 3, positive 4, 5, 6. And then if we go the opposite direction, we're going negative. So negative 1, negative 2, negative 3, negative 4, negative 5, and negative 6. All right, so that looks very similar to just a normal number line that we're used to seeing. The y-axis one is maybe the one that's a little bit odd because we're going up and down. The key to remember here is where the positives are and where the negatives are. So the positives are to the right on the x-axis, and they're on the top for the y-axis. All right? Very good. Now, if you kind of think about how this works, let's just get the terminology out of the way. When you have this set of number lines, they kind of create 4 sections, right? You can kind of see these 4 sections of the graph. You got a section over here, you have a section over here, and over here, and over here. So because of that, we actually give them names, and we call them quadrants. All right? So this would be the first, let's see here. I want to put this somewhere where it's not going to get in the way later. We'll call this the first quadrant. All right, so we kind of start on the positive sides where everything is, positive on the number line here and then positive on the number line here. This area is going to be the first quadrant. All right, then we move counterclockwise. So maybe a little bit counterintuitively, but we move to the left. This becomes the second quadrant over here. And by the way, quadrant makes sense because quad means 4, and we have 4 sections. So that's why we call it a quadrant. So first quadrant, second quadrant. This is the third quadrant. And then finally, of course, this is the fourth quadrant. Okay, so that's just some terminology. So as I'm doing this, it's actually a really good idea to write kind of your own version or draw your own version of this in your notebook so that you can study it later. All right, so you have the first quadrant, second quadrant, third quadrant, fourth quadrant. All right, that is essentially all we need to really know at this point about the Cartesian coordinate system. All right, as far as its setup goes. Now we can look at how to actually plot or graph these points on this system. Okay, so how do we graph ordered pairs? Well, if you think about any location, you pick a location on this graph, at any point where you see, 2 lines intersect. So maybe I pick this point, or maybe I pick this point, or this point. Okay, if I'm picking these points, I can locate them based on where they are in relationship to the value of the y-axis and the value of the x-axis. All right, so if I pick this point, for example, I might say, okay, well, that is in line with, if I follow this line straight across, it's in line with the 4 on the y-axis. And if I follow it straight down, it's in line with the 5 on the x-axis. All right, so kind of looking at where this falls in relationship to the x and y axis can indicate where it's located. All right, so we're going to use that idea to plot these ordered pairs. So this first ordered pair is a 1 and a 4. Now remember that 1 represents x and the 4 represents y. So the 1 we would find on our x-axis. Well, that would be right here, right? There's the home for 1 on the x-axis because 1 represents x, okay? So that's where it is on the x-axis. And then on the y-axis, we would go to the 4 because that represents the y. So we go up 4, okay? Here's the 4 axis, okay? Now we look at, if we were to draw, follow these lines from those 2 points, where do they intersect? So if we kind of draw this up, where does that go? And where do they intersect? They intersect right at this point. So this point would be the graphical location of the point 1, 4. Okay, do you see that? You went over 1 on the x-axis, up 4 on the y-axis. That gives you the location. All right, so where would, well, and my graph is a little bit small, so let's make these numbers fall in our graph. Let's say we've got, change these a little bit. Let's go with a 2, 5, and maybe a 3, -2, something like that. All right, so if I have a 2, 5, where would that location be? Well, let's look at it. So we have 2 on the x, that puts us here. And then we're going to keep going up on the 2 until we hit 5 on the y. So we go 2, we follow that up until we hit the 5, and that would be the home for this point, 2, 5. All right? The next one, 3 and -2. Well, here we'd have 3 on the x, puts us here, but now we need to find the -2 on the y. So we don't go up 2, we're going to actually go down 2 to this location right here. And notice where that is. It's on the 3 for the x, it's on the -2 for the y. All right? It's as simple as that. Let's try a couple more. What if I've got, I don't know, let's say a -2, 4. All right? What would we do there? Well, the x is the -2, so we have to find -2 for the x, and then we have to go to the 4 for the y, which means we're going to go up, follow it up to the 4. That is the point for -2, 4. All right? What about -2, -2? Where would that be? Well, again, we go to the -2 on the x, but now we go down 2 to get to -2 on the y, and that would be our point. Okay? What about, well, let's see here. 3, -5. Where would that be? Well, let's find the 3 on the x, find the -5. We're going down on the y. That puts us way down here. Okay? And then finally, what about this one? What about 0, 0? That's also an ordered point. X is equal to 0, y is equal to 0. Well, there, you're going to be right on the center. We have a name for that. We call it the origin. All right? Maybe I'll even just draw an arrow down here and say that is the origin. Okay? 0, 0. All right. Excellent. Very good. So that is how the rectangular coordinate system works. Actually, before we stop, though, let's reverse this. What I want you to do on a separate sheet of paper right now is just write the ordered pair, or the point, represented by this point on my graph. So if I have this point on my graph, what's the ordered pair for this point? Go ahead and write that on your paper, and then we'll see if you got it right. So the ordered pair means we have a set of parentheses, 2 numbers separated by a comma. The first number is the x-coordinate. Well, where is this on the x-axis? It's on the 4. Where is it on the y? It's on the 3. That would be our second number. So the ordered pair is 4, 3. Okay, let's try another one. What if I have this one? This point. What would be the ordered pair? Well, again, we go to the x always first. That would be a negative 4. And then from there we go to the y. The y is on the 1. So it would be negative 4, 1. Right? How about this one? How about this point right here? What would that be? Well, let's think about it. Where's the x? The x is, well, it's obvious. It's right on the 5 for the x-axis. So we have a 5 for the x variable. And where is it on the y? Well, it's actually, if we follow this over this direction, we see that it's on the 0, right? It's this blue 0 right here. It's on the 0 for the y axis. So this would be 5, 0. Okay. All right, what about this one? What if I have a point right here? What would that be? Well, let's look at the x. The x is actually on this. In this case, the x is the one that's on the 0 location. So we're going to have a 0, and then the y-axis is on a 3, so it's going to be y, or 0, 3. All right? Okay, and I think those are about as tricky as it's going to get right there. So should be pretty easy, not hard to do, and we will be using this a lot. So become very familiar with the Cartesian coordinate system. We're going to be talking about it more tomorrow and in future classes as well. And just as a quick summary, we talked about polynomial equations, right? Polynomial equations, just polynomials set up to with an equal sign. We talked about ordered pairs. Ordered pairs are the solutions to polynomial equations of two variables. And then we talked about the Cartesian coordinate system, where we learned how to graph those ordered pairs on a Cartesian coordinate plane. Excellent. We will stop here for today, and we'll pick up on this again tomorrow. Good luck with the seat work.